Good morning, girls. Today we are going to see the last chapter of the syllabus, that is numerical integration. Okay. So this is another application of interpolation. We are going to use the interpolation formula to find out integration formula. Okay. So what is the meaning of integration? Can you tell me? What do you mean by integration?
Sum of n numbers.
Sum of n numbers. Is it sum of n numbers? Then if you want to sum n numbers, do you need integration? It is basically summation. To integrate means to unite, to add, right? To sum up, right? That is the meaning of integration. But when I write integration a to b fx dx, what is it called? When you put these limits, what is this type of integration called? You have integration without limits also.
Integration.
This is
Definite integration.
this is definite integration and this is indefinite integration, right? So when you come across definite integration, how will you geometrically interpret it? What do you mean by integration a to b fx dx?
X from A to B.
Sorry.
Like into.
So basically, the AB values, they lie on which axis? The AB values are for which variable? The function is expressed in terms of x. X is usually an independent variable and y is dependent variable, right? Your fx is nothing but y. Okay, y is a function of x and you want to integrate it. So these AB values lie on which axis?
X axis.
They lie on x-axis, exactly. So suppose there are a and b and the function's curve goes like this. Then what do you mean by integration a to b fx dx?
All the points from A to B will be summed. All the points.
That means it is area under the curve, right? You want to cover this particular portion. Okay? That means it is an irregular shape, right? It's a polygon, but it doesn't have a regular shape. Does it have a regular shape? Can you say it is a triangle or rectangle or a quadrilateral or a pentagon or a hexagon? It doesn't have a regular shape, right? And you want to find out the area under this curve, which is bounded by two lines, the positive x-axis, the two lines x equal to a and x equal to b. Okay? And the curve y is equal to fx. So basically definite integration means the area under the curve bounded by the lines x equal to a and x equal to b. Have you all understood it? This is just a revision I am doing. You tell me all these answers, okay? So please remember that definite integration or integration means an area under the curve, okay? Now, why we are going to use numerical integration? Because you have studied integration already and you have seen the vast nature of this particular topic. Integration comes under calculus, right? So you have seen the vast nature of this subject. You have seen what is limit, differentiation, continuity, and integration. So there are so many formulae available. Then why do we need to use numerical integration? Throughout this numerical analysis Can you tell me why do we need all these numerical methods? When there are several direct methods available, why do we need to find out root of a polynomial using regular falsy method? Using Newton-Raphson method. Why
To get more accurate answers.
Sorry?
To get more accurate answers.
Don't we get more accurate answers using this if I am solving this polynomial? What is the answer of x? How do you solve this polynomial? Do you use regular falsity to get exact answer for this? You simply factorize this, right? Vipashini, x square minus 3x minus 2x plus 6 is 0 and you get x is equal to 3 and x is equal to 2 for this kind of polynomial. You directly factorize the polynomial. Will you use Newton-Raphson or regular falsy for such type of polynomials? Is it recommended? Please answer my questions. Don't waste the time.
Ma'am.
Do we use regular falsy or Newton-Raphson for this kind of polynomial?
No, ma'am.
No, because here factorization is available. You are directly getting the answer. Whenever you don't have formula available directly, whenever you are dealing with such kind of things, can you factorize this kind of polynomial easily? X cube minus 17x plus 81. Can you factorize it easily? You cannot. You cannot factorize it easily. Every polynomial cannot be factorized easily into such kind of factors. And therefore, we take help of regular falsy and Newton-Raphson, where we get something which goes close to the answer. We don't claim that in certain number of steps we will get the answer. Here, when you apply factorization, you get the answer quickly and you get the exact answer also in one attempt. But in regular falsy Newton-Raphson, you don't get the answer in one attempt. Okay. So throughout this numerical analysis, we are trying to get approximated answers. We are trying to minimize the errors, etc. Now, in case of integration also, there are some functions, they may be very complicated, right? What is the integration of x raised to n? Can anyone tell me what is integration x raised to n dx?
X raised to n plus 1 upon n plus 1.
It is x raised to n plus 1 upon n plus 1. I need to write this very carefully. Girls, let me just put on my laptop on charging, otherwise it will shut down. Yeah. Just a minute. So it is x raised to n plus 1 upon n plus 1 plus c when you are talking about indefinite integration. When you put a and b, this constant also goes, right? Correct? So you can tell this answer because you know that this is a very standard function and it can be integrated using the formula. But does it mean that every function can be integrated using formula? For every function, do you have formula available? Any function I can give you. There are various ways of integrating functions. Product of two functions, you can use by parts, you can use partial fraction. For polynomials, rational functions, you have those 6 keys of integration. There are various. In standard, trigonometric functions. Their standard answers are available. But does it mean that you can integrate each and every function very easily? If I give you e raised to x sine inverse x into log of 4x into x cube, can you integrate this function very easily? Girls, do you listen to
No,
me?
ma'am.
It's very complicated function I have taken, right? But does it mean that there is no integration available? You cannot integrate. In mathematics, there is solution to every problem, right? You can use mathematics and you can get the answers. Wherever there are complications, we take help of numerical methods. Always remember this. Therefore, we come across numerical integration. So the functions which cannot be integrated very easily, the integrands are very complicated, we take help of numerical integration techniques. Okay? And this formulae, there are three formulae we are going to derive. Trapezoidal rule, then there is Simpson's 1/3 rule, then there is Simpson's 3/8 rule, and these three rules we are going to get using something called as general quadrature formula. Okay, and this general quadrature formula is derived using this general quadrature formula comes from Newton's forward difference interpolation formula. Okay, do you understand the order in which we are going to proceed?
Yes, ma'am.
Yes. Okay, so this is absolutely mechanical in nature. The chapter, the rules, the derivations, they are very mechanical. Mechanical in the sense, do this and do that and you get the answer. Okay, and then substitute the things, substitute the values in the formula, get your answer. So it's absolutely mechanical. But have you understood the theory behind it? Why do we need numerical integration? That is more important. कैसे करना है, इसलिए इससे ज्यादा इंपॉर्टेंट क्या होता है, क्यों करना है. Okay, why is more important than what, isn't it? Reasoning is more important. Yes. So we are going to have Scilab programs also. Okay, on all these three rules. So whenever we'll finish this, after that probably in the next semester we can perform these programs. So please do not forget, do not throw your notebooks. I hope all of you are writing these things in your notebook, because ultimately you have to prepare for your exams from your notebook now. Okay, and watch the videos. Please start preparing for your exams. Yeah. So let us see what is general quadrature formula.
And we will have our exams, first semester exams.
Now see, we are supposed to finish the syllabus by 5th of December, Avantika. Okay. And
Yes, ma'am.
after that, your exams will be declared, the exact timetable. Okay. So maybe sometime in the December end or January. So I told you long back, you start preparing. Okay.
Okay, ma'am.
Or 15th December anytime. Okay, 15, 28 December के बाद कभी भी हो सकते हैं. Yes, but again I don't know exactly, and I'm not an official person also I don't know. Nothing is decided yet. Yeah. So let us first derive general quadrature formula. Okay, and using general quadrature formula, we will derive these three. I will first tell you the basic idea before actually deriving it. What we are doing here, as I showed you in the last slide, that there is a function which I want to integrate. Suppose this is my function and I know what is my function y equal to fx. Function मुझे पता है. I know in which interval I want to integrate it. Okay. So the basic idea is you divide the given this figure into possible number of trapeziums. Okay, like this. Because you know what is the area of a trapezium. What is area of trapezium? Can you tell me? What is area of trapezium? This is a trapezium or trapezoid? Yes or no? Am I audible? And is it visible what I am drawing?
Yes, ma'am.
Yes, ma'am.
So tell now, क्या है? क्या कह रही हूँ मैं? So what I'm doing, I'm dividing this interval AB into finite number of subintervals. This is very important. Finite number of subintervals of equal width. Okay, ये जो आपको दिख रहा है ये width equal है. This is h. ये distance भी h है. This is also h. This is equal width, equal length of the interval. And the first point I'm going to call as x0 and the last point B I'm calling as xn. Okay. So totally how many points I'm considering? x0 up to xn means how many points I have? How many points I have?
n plus
N plus 1.
1 points. And therefore n plus 1 point से कितने इंटरवल्स बनेंगे? अगर एक इंटरवल बनने के लिए मुझे 2 पॉइंट्स लगते हैं तो n plus 1 पॉइंट से मेरे कितने इंटरवल्स बनेंगे?
n inter
ओके, n इंटरवल्स बनेंगे. 3 पॉइंट से 2 इंटरवल बनते हैं. Okay, so what we are doing actually, we are dividing the given interval AB. Lower limit to upper limit is considered as an interval on the x-axis. That interval is divided into finite number of subintervals of equal width, and we are basically considering, suppose when I'm considering n equal to 1 in general quadrature formula, I'm considering one trapezium and I'm adding these. So I will find out area of this trapezium and I will add all these areas. So what happens, this portion which I am shading by blue color, this portion gets deleted. Do you understand it?
yes ma'am.
And this portion gets added. See, here it is getting added. I am making all possible trapeziums and I am adding area of all these trapeziums so that I will get area of this whole curve, area under this curve. And where sometimes I am deleting some portion, sometimes I am adding some portion, and therefore the answer which I get, that is an approximated answer with minimum error. Okay? Is that clear? See, let me just show you one more time. Here I have divided this interval into 6 intervals. Say, suppose I have this curve and I am dividing this into only 2 trapeziums. So how I will get the trapezium? Now this is a rectangle only. So this rectangle I am getting, and this is I am getting. And what I am going to, now this portion I am not considering, and this portion I am considering, I am adding. Okay, so this is a very big area, right? Very big area you are not considering or you are deleting. So when you have only two sub intervals, you get a very you get an answer with a big error. Do you understand it? Girls, please answer my questions.
Yes, ma'am.
Huh.
Yes,
Now
ma'am.
suppose instead of two trapeziums, two subintervals, if I have four subintervals now, then what happens? Then I get trapeziums like this. Okay. And what happens? The area
Error
which I'm going to
decreases.
add or delete, that becomes, the error is smaller, right? When the number of intervals increases, the error decreases. Now suppose I have again, now instead of 4, I will divide it into 10 subintervals. Okay, or more number of subintervals. So now I'm getting these trapeziums like this. Okay, and what happens? I may not be very accurate while drawing these trapeziums. What happens? But this very small area is either getting deleted or added, right? So error becomes still smaller. So the more number of intervals you have, the minimum error you will have in your answer. Is that clear?
Yes, ma'am.
Yes. Okay. So
Yes, ma'am.
yeah. So that's why we are going to consider three different things when we will put n value in the general quadrature formula, n equal to 1, 2 and 3, so on. And we will get better this thing formulae which gives us better answers, but there are certain conditions we need to follow. So let us first today see general quadrature formula. So whatever we can finish today, let us see. And of course we are considering equidistant, as I told you that these points, okay, x0, x1, x2, they are equidistant. That means difference between two consecutive points is same. We are considering the intervals of equal width, okay, and therefore these x0, x1, x2 up to xn are equidistant point, and therefore we can make use of Newton's forward difference, because in Newton's forward or backward difference our points are equally spaced. Okay, are you getting it? For equidistant
Yes, ma'am.
points, equidistant points, okay, please remember this is very important. हम ऐसा नहीं कर रहे कि हम हमारे दिए गए इंटरवल को 2-3 इंटरवल्स में ब्रेक कर रहे हैं, एक की विड्थ 1 है, दूसरे की 2 है, तीसरे की 3 है, ऐसा नहीं चलेगा. You have to divide the given big interval into सब intervals of equal width. जैसे कि आपके इंटरवल की लेंथ है 10, then you have 10 intervals of width 1. Okay, or you can have 5 intervals of width 2. Something like that you can do. Each interval should have the same width. All intervals should have the same width. Let, are you writing it?
Yes, ma'am.
Let I be
Yes,
equal
ma'am.
to a to b y dx, where y is equal to f of x, be given. So you know the function, okay? Function is given to you. Be given for certain equally spaced values of arguments. Arguments means x values, okay? Arguments, that is x values. Say x naught. So x naught is equal to a. A is equal to x naught, I will write. Then x1, x2 up to xn, and xn is going to be b. Okay. Where a is x naught, then x1 is equal to x naught plus h, x2 is equal to x naught plus 2h, and so on. Xn is equal to, how will you write xn? X naught plus nh, and that is nothing but b, the upper limit. Okay. So the lower limit is x naught, that is a, and upper limit is xn, that is b. Have you understood this? These are the prerequisites we need.
Yes, ma'am.
Let the range, that is length of the interval, okay? Let the range b minus a be divided into n equal parts n equal parts, each of width h, each of width h. Is finished writing?
Yes, ma'am.
Yes, ma'am.
So ऑलरेडी हमने लिखा है what is x naught, x1, x2, etc. हमने वो लिखा है. So totally how many points you have? N plus 1, right? Thus we have x naught, x1, x2 up to xn. Arguments. Arguments means x values, right? And y naught, y1, y2, and let y naught, y1, y2 up to yn be the coordinates, that is y values. Corresponding to above arguments. So we have n plus 1 arguments and n plus 1 ordinates. Okay. We have n plus 1 x values and n plus 1 y values. Now we are going to do certain substitutions, okay, in Newton's forward difference formula. Tell me, your y is expressed in which variable? If you consider Newton's forward difference formula, then it is expressed in which variable? Girls, are you there?
X.
Is it expressed in x? Diona? Is it expressed in x? Y naught plus u delta y naught plus u into u minus 1.
U, ma'am.
It is expressed in terms of u, and we are given function in terms of x. Okay, therefore we need to make change of variable here. Okay. So consider Newton's forward difference interpolation formula. So what we will have to do, if I want to integrate this function now, I am considering y in terms of this. Okay. So I have to integrate my function for or with respect to u. I cannot integrate it with respect to x. Therefore, I have to use the change of limits technique. Okay. So we will see that in the next lecture. I have to stop here now.